All right. So still continuing essentially with chapter 7, but we're just going to take a little look at this one section from chapter 6. So this is on increasing, decreasing, and constant intervals, piecewise functions, and then their applications. So we want to determine, here we go. It wasn't going. So on a given interval, if the graph of a function rises from left to right, there we go. Okay, make sure I was in the right spot. So on a given interval, if the graph of a function rises from left to right, it is said to be increasing on that interval. If the graph drops from left to right, it's said to be decreasing. If the function values stay the same from left to right, the function is said to be constant. So this is a more formal definition, but this is what we mean by increasing interval. So as I go left to right, so I'm going in this direction, what we see happens with the graph is like going upwards. It's rising. So the other way this is defined is that for all A and B on the interval, so here's A and here's B, B is something that's greater than A, we want to make sure that f of B is also greater than f of A. That's another way to define that we're increasing our interval. So this is a more official definition. But like I said, another way to think about this is the curve or the line, it goes up from left to right. If the function is said to be decreasing on an open interval, so we have A and B, we still have B is something that's greater than A, meaning we're going left to right again. What we notice is that your f of A is actually going to be greater than your f of B. And that signifies that we're having decreasing. So once again, another way to think about this is that your curve or line, as we go from left to right, is actually going down. So as we see, it's slowly going down. A function is said to be constant on an open interval if, for all A and B on that interval, we find is that f of A and f of B are going to be equal to each other. So what we're saying here is that essentially that there's no change, everything stays constant. So another way to think about it is the line or curve is flat or horizontal as we go from left to right. So we go left to right, what we see is that we don't go up, we don't go down, we just stay the same. So what we want to do is talk about where this function is increasing, decreasing, or constant. So notice back here when I was talking about the interval, I said it's going to be an open interval, meaning that we treat this point and this point like they're going to be open. So we're going to have parentheses. So we'll explain that here in a little bit. So if we're looking at this one, even though there's closed points, when we write our intervals, we're going to break our intervals with open points, or like I said, parentheses. So this function where it starts decreasing as we go left to right, we see it goes up. And then at this point here, it does start to go down. Then it hits this point here before it starts going up again. So the part that's decreasing is right here. So we're going to record the x values that this happens on. So like it's the domain this occurs on. And this is occurring as long as x is somewhere between 1 and 4. Or the other way we like to write it is an open interval, an interval notation, 1 to 4. Increasing, going left to right, you see it's going up. So from this point to this point, we see that we're going up. So we're increasing between -1 and 1. Like I said, we're not including -1 and 1. You may have also noticed that we're increasing in another spot. We're increasing here as well. So we're increasing here once again from 4 to 5. So if you have two intervals that are supposed to be together, so we just want where it's increasing, we're going to put this U. It means a union. So it's telling me that those two intervals belong together. They're answering the same thing. This is the interval in which I'm increasing on. Where we're constant would be right here where we're staying flat. So we're staying flat from 5 to 7. So just to explain why we're talking about open intervals, we're using that same graph. So if we look at this point here, so this is x equals 1. What we have is on one side, we're increasing, and then the other side of this point, we're decreasing. So the problem that we have here is that I don't know what to say that what x of 1 is at. Is it part of the increasing? Is it part of the decreasing? Because it's the border between both of them. So because it's the boundary where one ends and the other starts, what we do is we just take it out of the interval, because for it to be increasing on an interval, the point to be included, like this point here is included on the increasing part, because I'm increasing on both sides of it. Same theory. This point's part of my decreasing interval because I'm decreasing on both sides of it. The problem here is that I'm increasing on one side and I'm decreasing on the other side. I'm not doing the same thing. So that's why we pull that point out and we don't include it on those intervals. So right here, we'd say it was like increasing from -1 to 1, and we leave it open because then on this part here where it's decreasing, like I said, I don't know where to say that I would include that point on because it's not doing the same thing on both sides of that point. So those points where we change from increasing to decreasing, decreasing to increasing, increasing to constant, constant to decreasing, all that stuff where there's a change, that does not get included in your intervals. Also, the endpoints do not get included either. Because if we look at this point here, x equals -1, it's definitely increasing on one side of it, but nothing's happening on this side. So I can't say that I'm constantly decreasing or increasing at that point, because I'm only increasing on one side of it and the other side has nothing. So once again, that's another point we leave open. So anything that's like an endpoint or where we change from increasing, decreasing, or constant, all of those places we just leave as open points, because we can't really definitely tell you what's happening at that point and include it as increasing, decreasing, or a constant interval. So just remember, keep your intervals open when you're doing this part. So if you take a moment, you have number 1 and number 2. Just go through it and tell me where you're increasing, decreasing, or constant. And just to point out, not all functions are increasing, decreasing, or constant. Sometimes they're just increasing, sometimes they're just decreasing, sometimes they're just doing two things. Now, they don't have to be doing all three. All right, so once again, where this is decreasing, that's all the parts I put in pink. So we see here at -5, I start decreasing. And I don't stop decreasing till I hit x is 0. So remember, we're talking about x values. We also see that we're decreasing once again once we hit here at 6. And we keep on decreasing. We assume that this line, when it goes off the graph, it's going forever. That is actually going to infinity. So as to write this in interval notation, we would say part of the interval in which is decreasing is -5 to 0, union, because then it starts again at 6, and that goes to positive infinity. Like I said, we're thinking about where x is going. X is going to positive infinity. Sorry, I had that right the first time. No, I was trying to correct. All right, increasing. So we see we're increasing starting at 0. We increase until we hit that 6. So you're noticing that we're like filling in these gaps, like over here, that gap from 0 to 6 gets filled in the increasing. Or another way to write that is just 0 to 6. It's constant where it's green. And so it's constant out here. So as you see, it terminates at this point here. So it is constant from -10. I'm having a hard time writing that 10 for some reason. Up till we get to that -5. Or as interval notation, -10 to -5. So here, we are decreasing. So you notice there's an arrow here, but we are decreasing until we hit the spot here at 1. So what we have is that we are decreasing as long as x is something below 1. And then we increase, and then from here to here, we decrease again. So we are going to decrease again when x is between 3 and 4. So as an interval, we would say, starting at -infinity, we were decreasing until we hit 1, union, and then from 3 to 4, we decreased again. All right, we use purple here, so kind of shows up, I'm hoping. We see increasing happens here from 1 to 3. We also see we increase again once we hit 4, and we start increasing, and we're just going off to infinity again. Like I said, you're thinking where the x values are going. So from 4 to infinity is the other part of this. Nowhere was I constant. So we'll just say an A, not applicable. There wasn't any place it was constant.